quick shot at a cost, volume, profit problem. Pretty straightforward one where we'll figure out what the break even is for a business. So cost, volume, profit analysis allows us to look at our business in different ways and gives us the tools to make some pretty quick judgments about volumes needed to break even, volumes needed to hit certain target operating incomes. Remember, the basic formulas are fixed cost divided by unit contribution margin to give us break even, or fixed cost divided by contribution margin ratio to break even. Fixed costs are the costs that don't change in proportion to sales. They might change, but not in proportion to sales. And unit contribution margin is how much we make on each sale expressed in dollars. Contribution margin ratio is how much we make on each sale expressed as a percentage. So when we divide dollars by dollars, we get the break even in units. We divide dollars by percentage, we get the break even expressed in dollars. Okay, here are the facts. This Sassoon Barbershop employs 4 barbers. And while I read these off, why don't you think to yourself whether these are fixed costs, costs that don't vary in proportion to sales, or variable costs, costs that do vary in direct proportion to sales. So they got one barber that makes $3,000 a month, 3 barbers that make $1,500 a month. In addition, each barber gets a commission of $3 per haircut. Other monthly costs are rent of $700 plus 60 cents per haircut to the landlord. Depreciation on the equipment is $400. Barber supplies are 40 cents per haircut. Utilities is $300, and advertising is $100. The sales price of each haircut is $10. So which of those do you think are fixed and which do you think are variable? I hope you got it. The fixed costs are the salaries, the rent on the store, the depreciation, utilities, and the advertising for total fixed costs of $9,000. The variable costs are the $3 per haircut, the 60 cents to the landlord per haircut, and the supplies of 40 cents per haircut. So the variable costs are $4. Since we sell our product for $10, what is our unit contribution margin? Our unit contribution margin is $10 minus $4 for $6. We make $6 on every haircut. And what's our contribution margin ratio? It's the same thing except expressed as a ratio. So if each haircut we charge $10 for and we make $6 on every haircut, that's 60% contribution margin ratio. So to figure out our break even in units, take our $9,000 fixed costs, divide it by our $6 contribution margin, and you discover we have to sell 1,500 haircuts. To get the same answer but expressed in dollars, we'll divide by the contribution margin ratio. So we'll take that $9,000, divide it by 60%, and we'll come up with $15,000. And that's the same answer, just expressed in 2 different ways. It takes us 1,500 haircuts to break even, and we charge $10 per haircut. That's sales of $15,000. Then the problem asks us to make a chart or a graph. So this column here is haircuts. This is an Excel. So 0 haircuts, fixed costs are $9,000, variable costs are 0, total costs are $9,000, total revenue is 0. If we sell 300 haircuts, our fixed costs are still $9,000. Our variable costs are that $4 times 300. So that gives us total cost of $10,200. This column out here is the revenue, which is $10 times the number of haircuts. All right, so let's see if we can create a chart that shows us a nice break-even point at 1,500 haircuts. All right, let's highlight this stuff in Excel, and let's go to the Insert Charts and insert a line chart. And this just looks awful. It's not what we want at all. So let's right-click on it and let's select the data. Well, we don't want the haircuts, we don't want the fixed costs, we don't want the variable costs, we just want the total costs and the revenue. And our horizontal axis, we want that to be the number of haircuts. So we'll tell Excel to use that for the labels. And now let's see if that looks any prettier. Well, that looks much better. And so here's our number of haircuts along here, 300, 600, 900, 1200, 1500, and sure enough, that's the point where our revenue line, which is this light blue color, crosses our total cost line, which is this purple color. And so anything above that, this is called profit area, and down here below that, we're losing money. And there's many different ways to answer the part D. You might say if we have 1,800 haircuts, that means we have revenue of 18,000. The cost per haircut is $4. So 4 times 1,800 is 7,200, which gives us a contribution margin of 10,800, minus the 9,000 fixed costs would give us our $1,800 net income. I prefer to think operating income. The book says net income. Or you could just say, hey, wait a minute, if the break even is 1,500 haircuts, then all our fixed costs are covered, and that $6 per haircut above 1,500 in contribution margin goes straight to the bottom line. So $6 unit contribution margin per haircut times 300 haircuts gives us $1,800 worth of income. And that's really all there is to a simple cost volume profit problem.